Great to see you here again. This is another video of the Math Survival Guide offered to you by the Ceuster Academy. My name is Luc de Ceuster, founder of the Ceuster Academy. In this video, I will talk about how we can find the numerator and the denominator, the integers that in fact define the rational number. And we will do some exercises. I will explain the principle, but before we continue, don't forget to subscribe to our channel, click on the button under this video, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look. When we look at the identification of rational numbers, we know basically that we have a rational number when we have two integers, a and b. When we divide a by b, this gives us a rational number on the conditions that b, the denominator, is not equal to 0. Now, when we look at a rational number q, we also have a very important property, which is in fact that a rational number has in fact a number of repeating decimals. And those repeating decimals are very important because when we see a number and we can identify repeating decimals, we know for sure that we are dealing with a rational number. Now, we have some examples here, 2.333, we have one repeating decimal, 4.5757, here we have two repeating decimals, and so on. But 1.234567 is not a rational number because we don't have any repeating decimals. Now, how do we find a and b so that the rational number is equal to a divided by b? So let's have a look here. We have a number q, 4.321321. We have three repeating decimals. And we know that this is a rational number because of the presence of those repeating decimals. What we have to find now is what are the values of a and b that define this rational number. We would like to write this number as a divided by b because it's nicer to work with. We can enter it in a program in an easier way, and a divided by b will give you the exact value because we know exactly what the integers a and b are. They don't have any decimals, so they are at 100% defined. Now, what can we do here? Now, let's start with a very simple example. Let's say q is 0.33. Okay, we know this is equal to 1/3. But just to explain the principle, how do we find a and b? Now, what do? We have one repeating decimal, so when we multiply q with 10, we find 3.3333. And what do we see? And that's very important, is that the decimals, the repeating decimals, are still there. All the decimals of 3.333 are there, and we see when we subtract q, we see that we remove all the repeating decimals, and that is the goal. We have one repeating decimal, we'll multiply by 10, so basically we have an integer number and an infinite repeating number of decimals, 333, which is basically the same, or are the same decimals as from 0.333. So when we subtract those two, we see that the decimals disappear. And we find that 3 times q is equal to 3, which gives us immediately q is 3 divided by 9, and we can simplify this because the numerator and the denominator both have the number 3 in common, and we find 1/3. So a is equal to a is equal to 1, and b is equal to 3. Let's now look at another number. And that other number is a little bit more complicated. So we increase the complexity, and now we have two repeating decimals. We have q equal to 0.7575. since we have two repeating decimals and we want to move the comma or the point just behind the first set of repeating decimals, we have to multiply here with 100. When we multiply with 100, we find 100 times q is 75.75, and so on. And we see that the repeating decimals are the same as the repeating decimals of q. Again, we subtract q from 100q, and now we find that 99q is equal to 75. We can write this as q is 75 divided by 99, but we want to simplify. We want to find the smallest numbers a and b. So basically what we can say is that when we factorize the numbers, we can say that 75 can be written as 3 times 5 times 5, and 99 is 3 times 3 times 11. And we can simplify with 3. So basically the smallest numbers in this case are 25 divided by 33. So a is equal to 25 and b is equal to 33. And basically that's the final thing that I wanted to show here, how you can find, or what is the principle of the method, how to find the two integers that define the rational number. You will understand easily that instead of writing 0.757575 and all those repeating decimals, it's more interesting and simpler and nicer just to write this as 25 divided by 33. Your equations, your calculations will be nicer, having only integers, if it's possible. It's not always possible, but anyway, we find a better and preciser way to write those rational numbers. So that was it for this video. I thank you very much, and of course, before leaving, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and bye-bye.